This is Dr. Moberly, and I thought I'd comment a little bit about the quadratic formula and its use in Kreyszigs' text in Chapter 2. Find the roots. The classic problem was presented with a quadratic equation. Find the roots. And you were told that the roots looked like minus b plus or minus square root of b squared minus 4ac all over 2 times a. And I think you may have remembered that in a song or something about a negative boy who couldn't decide about being square or missing out on a party with 4 awesome chicks that ended at 2 a.m. Whatever helped you remember that, let's just say that in the old world where Kreysig came from, just as you may have been restricted on when you use the quadratic formula, he was restricted to working with it in the monic fashion. And how would you turn this into a monic quadratic? Well, you'd say that the roots of this equation are in fact the same. It has the same roots, but is monic, as in there's a leading one here. It's implied. Now, how would that help you in solving the quadratic equation? Well, you would simply put these fractions into it. You'd put the b over a with a minus sign all over 2 times 1. And then you would put plus or minus square root of b over a squared minus 4 times 1 times c over a. And that would be if you simplified, b squared over a squared minus 4 times c times a, or a times c, and then minus b over a, and of course over 2. Now I think you can see that this square root becomes b squared minus 4ac all over square root of a squared, and you finally are looking at minus b over a plus or minus square root of b squared minus 4ac all over a all over 2, and it is exactly the same thing, minus b plus or minus square root of b squared minus 4ac all over 2a. So the quadratic is the same whether you turn it monic first or not. The roots are the same whether you choose to make it monic or not. So why does Kreysig then relabel this thing and relabel this thing to give them new names? Well, that's just the way he was taught, so that he was looking at the roots of 1 x squared plus a x plus b equals 0. And of course, when he did that, he used this reduced formula, which gives you a minus a plus or minus square root of a squared minus 4 times b, as he's relabeled this to be, calling this a and this b, and then divided by 2. And as if that is not going to make it hard enough for you, Kreysig also later in the chapter is going to put the minus a over 2 up here and do the plus or minus a squared minus 4b all over 4, and he's going to simplify it even further and put the minus a squared plus or minus square root of a squared over 4 minus b. And this is very compact, but only for a monic quadratic. So this is what he introduced in section 2.2 for monics. And then he'll introduce this other segment later. He will also put in the letters C, K, and M, where it looks like either M y double prime plus C y prime plus K y equals 0 for the differential equation, which we'll see has a characteristic like that. Or he will make it monic, which is to say he'll put this plus C over M lambda plus K over M. And when he does that, he puts these things into his quadratic in the appropriate places. And you'll benefit from trying to squeeze things into monic form, but you don't need to. You can work this non-monic with the quadratic formula. And I hope that you won't be stuck on the formulas within the book if you're comfortable solving quadratics and finding the roots, of which there are 3 types: 2 real roots, 2 distinct real roots, a double root, and complex conjugate roots, all dependent on what happens under the square root sign. All right, I'll stop.